and the coefficient of selection was about 2%, but now it's gone back. Air quality has improved, lichens have come back, the peppered form has returned, and it's sort of, there's an ebbing and waning of the whole process. Now here, what you're looking at right here is a group of related butterflies, all of which are very poisonous and have what are referred to as warning color. Many brightly colored, easily seen organisms are brightly colored because what they're saying is, if you mess with me, you're going to pay for it. But next to them is another group of butterflies that are very similar in appearance, but in fact are not toxic. Now what you're looking at here is a multi-stage evolutionary interaction that begins and ends with organisms that are not seen on this page. The starting of the interaction is plants, which, because they can just sit there and can't defend themselves by running away, often are toxic. They have powerful poisons in them that will deter herbivores. Some herbivores have evolved the ability to be able to eat the plant and resist the poison. Others of them have actually evolved the ability to sequester those poisons inside of their bodies and turn them to their own defense. And some of those who do that have then gone on to evolve bright coloration, because in that context, the bright coloration trains predators to learn more readily to avoid them. But then other butterflies have then evolved to look very much like the butterflies that are poisonous and are avoided, because in a sense what they're doing is parasitizing the protection that the poisonous ones have. And so the unseen members of this interaction are the plants and the predators. But the main point is that you're looking at like a 5-stage process to get to what you're seeing here, which is plants defending themselves, insects thwarting the defense, insects using the defense for their own purposes, then evolving bright coloration, and then having that bright coloration parasitized by others. Now, we have a name for this. This is called the Red Queen hypothesis, taken from Lewis Carroll's Through the Looking Glass, where the Red Queen said it takes all the running you can do to keep in the same place. The idea is that there's no predator that's so proficient at catching prey that it doesn't run some risk of starving to death, nor any prey that is so resistant to predation that it's entirely without some risk of being preyed upon. And this is the idea that Charles Darwin presented in The Origin of Species. Chapter 3 of this book was entitled The Struggle for Existence. And what he argued there is the main reason organisms evolve is because they're adapting to antagonistic interactions with other organisms. And there's a variety of antagonisms. There's predators, prey, there's competitors, and parasitism and disease. But his main point was that people may often think that evolution involves adaptation to the physical environment, to things like temperature or altitude or water availability. And his argument is that the physical environment is relatively unimportant, that if you really want to understand evolution, the primary players in evolution are biotic interactions. Whether or not that's true is something that people can still debate, but in fact, I think he's probably right about that, and that forms the conceptual basis for the work that I do. Now, what I wanted to do, my original career goal when I went into graduate school, was that I wanted to test some aspect of the theory of evolution in nature with an experiment. I had come out of more of a molecular cellular background, and we all did experiments. That's what you do. And that's what I wanted to do in evolutionary biology. And the original reaction to that proposal was that people would smile and say, that's a quaint idea, and we hope you live long enough to see something happen. Because at that point, we're talking about the mid to late 1970s now, the idea was that even though we know evolution is an important process, we also think that it's a very slow process, and that it's something that is not amenable to empirical study. Now, what I chose as the basis for my work was the theory of life history evolution. And the reason I liked that body of theory is that it incorporates a generalized concept of fitness. Fitness is what increases in response to evolution by natural selection. And to